Let's get started. First of all, I love Krakow, but for me, this is the most beautiful city in the world. This is Rotterdam. CNN did an article yesterday about Rotterdam, and they called it the new capital of cool, which instantly makes it uncool. But yeah. Well, for the last 10 years, I've worked on a project for the Port of Rotterdam, and their main building is this building right here. And that's not where I work, because they don't want developers in that building, so they put us in a container somewhere far away. But yeah, the real people from the company that don't make software are in that building. A disclaimer. This presentation isn't about like a microservice success story, like telling you all the good things that happened to us. It's also not a failure story because the project's still alive, so it's just a real-life example of a long-running project that has ups and downs, pros and cons, and maybe you can learn from it. That's my goal. So like I said, the Port of Rotterdam, the name of the project I'm working on is HAMIS. Originally, Rotterdam was the largest port in the world for a couple of decades, but right now there are harbors in China and Shanghai, and they've become much larger because of all the cheap goods coming from China that needs to spread over the world. But it's still a very big port in Europe. It's the largest in Europe. So, well, you can see that I don't have to read the numbers for you. You can read the numbers yourself. It's a lot. The system we make is called HAMIS, and that's basically, it stands for the Harbour Master Management Information System. It's a good acronym. The guy you see here, he's the Harbour Master. Basically, the Port of Rotterdam is divided into two parts. The first part is the commercial side. They ask money from each ship that comes into the harbor, they rent all the harbor space, and they're basically there to make money. The second part is the Harbour Master. The Harbour Master is a government official, and he's appointed, and his task is to keep the harbor secure and safe. And they've separated that, because it's conflicting, right? If you want to make a lot of money, you'll tend to lose track of safety a bit, and you don't want that to happen. So what does our application do? Well, basically everything in the harbor. So we've got an interactive map where you can see all the vessels. There are patrol vessels. They've got our application running on the vessels themselves. Whenever a ship comes into the port, they have to report they're coming to the Port of Rotterdam. They have to report what's on the ship, the dangerous goods, if they go through a lock or a levee, or well, basically anything you can imagine, it's in our application. So you can, basically, there are 450 plus users, which doesn't sound much, but every user is doing something different in our application. And I'm going to take you through a timeline. And as you can see, it starts very early, 2004, and it runs all the way to the present. The old application was called IVS, and it was a terminal console-based application, but they stopped making the hardware in the 90s. So the only thing we could do was, when the system broke, was to go on Craigslist, eBay, to find replacement parts. That has its limitations. So, thankfully, they started to think about a replacement. And because the Harbour Master is part of the government, they had to do a government procurement for HAMIS. So, who here knows what a government procurement is? Okay, so that basically means you write a piece of paper what you want, and companies can submit offers on how they are going to do the project. And that's government regulation. That's where the story actually begins. So we started with 15 plus architects, one developer. You need a developer, obviously. And they were using IBM WebSphere Partner Gateway. Seeing that you're all laughing, you can probably guess what went wrong. About a year later, the project was put on hold, and the only thing they had was 100 plus pages of blueprint document. We still have that. We have one locker with all the blueprints in it. we never look at it. Basically, the blueprint describes what happens in the harbor, how people work, what the system should do, what all the actors are, and we never look at it, never ever again. Basically because everything changed in the meantime. This is I don't know, almost 10 years ago. People are working in an entirely different way. Back then we didn't even have tablets, for example. Yeah, achievement unlocked. So, a couple of months later, they decided to ditch all the architects and hire developers. When you want software, that's kind of a good thing. And we started doing Scrum. And after 3 weeks, our first iteration, we started with 3 weeks iterations, we had something in production, live, that we could use. And that's been the basis of Hamis from then on, up to the present. So every sprint, new functionality goes into production. And actually in 2009, we were one of the first, in the Netherlands anyway, that were already doing this and doing that successfully. A couple of months later, I joined the team. You can see, I didn't even have a beard back then. And we have a creative team. So the building I pointed out at the start of the presentation, there is a very large video wall where they can see the entire map of Rotterdam, and you can see all the ships. But it had performance problems. But yeah, we couldn't take that video wall and put it in our dev environment and start to hack on it. So what we did, I just scoured all kinds of monitors. In the end, I had 6 different monitors. I took my home gaming PC, put some extra hardware in it, and I made my own video wall. Well, it looked like crap, but it worked, and I was able to find the memory leak and to fix it. But it only appeared when the screen was large enough. So it's a creative team. Oh, now I've got a beard. Sprint 70, a couple of years later, and a glorious moment arrived, because finally, we could turn off the old system. IVS, finally, we didn't have any hardware, but we could turn it off. And it was a glorious moment. You can see, everyone is partying, and this is where it's happening. There's one guy turning off the old system. But look at these guys. It was the most boring moment in my life. We've been working on that for 5 years, and I was anticipating like a grand party where we turn off the old system, and we were all anxious because the new users would use the new system. But over those 5 years, we slowly migrated to the new system. Every week, new users would start using the new system and would abandon the old system. At this moment, for 3 or 4 months, no one was using that old system. So turning it off was like, okay, I'm gonna turn it off now. Sure. But we had cake, so it was kind of a party, but that's about it. So that's one drawback of agile. You don't get to have that moment. It's the most underwhelming thing in my life. Sprint 100, well, we figured 100, cool number, not a party. But we started to notice something. The application grew and grew. We got more users and more epics and more functionality. And then about, it says 2016, oh, maybe it is true. About a year ago, we said, we need to do microservices because we need to do that. I'll go into that later, but this slide is actually incorrect. The team, we have multiple teams. We had 5 teams with 5 people, but starting Monday, we now have 4 teams with 6 or 7 people because we decided it was better to have 4 teams than 5 teams, and yeah, that's why we did that. And our teams are 100% cross-functional. So that doesn't mean we have a database expert. We have one, Ramon. He's been with us for 15 years. But if I need to do something in the database, I do something in the database. If I don't know how to do it, I'll go to Ramon, ask him, next time I know how to do it. That's how we think cross-functional should be. You should learn the skill. Sure, you have experts, but you can learn the skill yourself. And then next time, if someone has a problem, they'll come to me and I can tell them. And that's how we spread the knowledge over the team. This is basically what the application looks like. You can see all kinds of stuff. It's fully customizable. There are dockable frames. You can open a lot of frames. They're like 50 or 60 frames, and you can dock them and move them around, scale them. We've got this interactive map with all the vessels. They're moving. It's coupled to a radar system. You can click on each vessel, and you can see what's on board and how many people are on board, where it's going. That was made entirely in Swing by us. And one important thing is the application is offline available, because the application is also used for inspectors, and those inspectors need to inspect the ships. For example, if people are not smoking when there's fireworks on board. Like, that's a dangerous combination. So for safety, they need to inspect the ships. If there's fireworks on board, you can't have a phone or a laptop or a tablet. So you need to turn off all electric devices when you go on board until you are in the captain's cabin and you're interviewing the captain. That's when you can open the application, that's when you can connect, and that's when you can fill in the checklist. But a ship is entirely made of metal, and it's a cage, so it's a huge cage of Faraday. There's no way to get internet inside a ship. So one of the key things was this application needs to be offline available. We need to be able to start it offline, fill it in, see the information, see which ship has to be inspected next, and continue when you've got network again. Also note, we started in 2006 or 7. There was no 4G or 3G connection. That was very expensive at the time. So yeah, if you're outside, you have no internet. So how did we make this? The front end is Java Web Start. We are using Jite, a docking framework, and the panels are made in Swing. And the communication to the backend is Hessian. It's a binary protocol where you simply call your Java code like it's locally, but it's actually remote. And it works very well. We have almost no problems with Hessian. The backend itself, it was a Java EE application running on Yabel's application server, and we slowly migrated to Wildfly 10, which is, I think, the latest version. I'm not sure. But we were running 2 nodes with shared state, like the worst mistake we made. And we were using Hazelcast to synchronize the data. The data we needed to synchronize was the vessel information. So if you update a vessel, it will be, Hazelcast would make sure the 2 nodes are up to date. And eventing was also done using Hazelcast. For the database, we used an Oracle database with Hibernate, because that's what you do in 2006, 2007. So, some of the lessons we learned and some of the mistakes we made. Like I said, teaching is very important in our team. And for me, teaching is learning something the second time over. When I was making these slides, I learned a lot about my own project. When I tell my colleague about Wildfly, I learn a lot about Wildfly myself. So not only do you teach the other guy, you're teaching yourself as well, which is very important. Always experiment. If you do an experiment, we do a lot of proof of concepts. If it's successful, great. If it's unsuccessful, even better, because then you know the limitations. If a proof of concept was okay, maybe there is a limitation, but you just haven't found it yet. So when things fail, that's a good thing for us. James C. Collin, he's a genius guy, but he talks a lot about, oh God, I hate this word, bureaucracy. Like, that's okay, right? Bureaucracy. And he says, bureaucracy is compensating for the incompetence and lack of discipline. And I completely agree, and this is something I see a lot in our project as well. And he also has the spiral of bureaucracy. As a project grows, you get more actors and more functionality. That's when the application becomes more complex, obviously. And then you get the feeling, well, I don't completely understand our system anymore. We need to manage this some way or another. So what do? We define rules and paperwork, and we define standard procedures, and that's how we manage this complexity. That's how you get bureaucracy, and that's when creativity decreases, and also your responsibility decreases, because the responsibility is now in the rules and in the procedures, not in the people. So one thing I noticed, for example, was when we started doing Scrum, you have a definition of done. So you work, and after 2 weeks, you check your story, and you check the definition of done, and it says things like, you've tested your code, you've put it in the test environment, you made an integration test for it, you showed it to the product owner, all kinds of stuff. And every time something went wrong, we could make a new rule and add it to the definition of done. Because, yeah, that's what you do. Eventually, our definition of done had like 40, 50 bullets. And that's just shifting the responsibility to your definition of done. But if your definition of done has 40 or 50 points, no one is going to follow those 40 or 50 points. So eventually, people stop thinking, because you're not responsible anymore. The document's responsible. And nobody's using the document. So that's when we decided, oh, you know what? Let's just scrap the entire definition of done and use common sense. Until something goes wrong. Then someone says, wait a minute, we should make a rule for this. Maybe a definition of done kind of thing. So, and we've had that, I've been in the project for 10 years, so I've seen that like a lot of times, like more definition of done, no definition of done. Now we need some, oh, that's too much. Like that wave motion is constantly happening in the project, on all fronts. Like I said, we were using Scrum, but it's just a set of best practices. Don't just blindly follow those rules, apply them where they're needed. So basically, ask yourself, why are we doing this? Last week, I asked my colleague, why are we doing a daily stand-up? It's like, we're doing Scrum, we need a daily stand-up. Yes, but why are we doing a daily stand-up? What are we learning from a daily stand-up? And come to think of it, we couldn't really think of something. We're constantly talking to each other, we're constantly using Slack as a communication tool. At every moment in time, I know exactly what all my colleagues are doing. We're just a team of 5 people. If I don't know what those other 4 are doing, then... So why do I need a stand-up? I'm not going to wait until tomorrow morning to tell my team what I'm doing, what I plan to do. So we just stopped doing it. It wasn't adding anything, it was just costing time. So don't do agile, with a capital A, be agile. Be open for change. Technical debt, something we struggle with, but I think all big projects struggle with. But how can we define it? Well, for me, I like to think of it as this picture. I think this picture is from a colleague of mine. If you have a positive thing, a thing that adds value to your product, and it's visible, that's what we call a feature, right? We build features. If it's a negative thing and you can see it, it's a bug. But the same is true for architecture and technical debt, but they are invisible. So if it adds to your application and it's invisible, that's what we usually call architecture. And if it's a negative thing, we'll just call it technical debt. But that kind of makes it clearer what technical debt is. We've noticed a spiral of technical debt. The velocity goes down. We measure our velocity, we measure how quick we're going in story points, but it tends to go down and up and down. What do? We start to take shortcuts. Because, yeah, you focus on the functionality, you create user stories, just leave that quality thing for a while, or leave that architectural thing for a while. But eventually, the velocity goes down even more. You need to take more shortcuts, etc., etc., etc. There's another debt trap you can fall in, and you need to be aware of. If you look at Wikipedia, the definition of software architecture is about making fundamental structural choices in your application, which are costly to change once implemented. When we started this project, we had one architect. We hired one for a couple of months until he moved to Hong Kong. Sadly, I would love to have him on. He's like my big example, my big role model. But from the beginning, he said, always design for change. And if you do that, you don't have any architecture because nothing will be costly to change. Of course, there are decisions that you make that are costly to change, but if you keep in mind it might change in the future, that's a much better approach. And we've done that for the last 10 years, and we still do that, and it works very well. Also, we like to think of it as just-in-time architecture. This is something that Mary Poppendieck invented, and she says you have to find the last responsible moment to make a decision. If you make a decision up front, you're making a decision with almost no knowledge, very limited knowledge. So that's not a good moment to make a decision. If you make a decision too late, the word implies too late, it's too late. So you have to balance it out. You have to try to make the decision as late as responsibly possible. How do you do that? Well, but that should always be your goal. And at any point in time, just do the simplest thing that could work. And that's one thing we've done for the last 10 years, and that's working very good for us. Just keep it simple. Don't make a grand design and follow the design. Just do the simplest thing that could work at any given time. Some people think architecture is something you write in a document, but it isn't. I think every line of code is part of your architecture, because every line of code can change a dependency. Every dependency you add in your Maven POM changes your architecture. And even on a lower level, every line of code, every class you call, almost starts to sound like a song, every class you call is another responsibility you add to your code. So literally every line of code could make your, well, it not only could, makes your code more complex, but could make it a lot more complex if you don't really think about it. So architecture is about code and not documents. We don't have any documents. We have a wiki with a little description, but it's really outdated. We just document our code, and it should be easy to read. So architects. Yeah, well, we had 15 of them. We fired all of them. We spared no one. And we decided, well, architecture is a shared responsibility, because everyone writes code, everyone changes the architecture, so everyone is responsible for it. But how do you do that? Well, we made a tribe. So basically every team has one person that goes to the tribe meeting, and they brainstorm on stuff, and they create a vision where the product should go in the next year or longer. And then if you want to change something, something that's not functional, but something that's like a technical story, you go to the product owner and you prioritize this. And in the beginning, this was hard. The product owner obviously wants functionality. But if it's important enough to, I don't know, move from Wildfly 10 to Wildfly 11, if I think it's really adding something, I should be able to convince my product owner. And that's the motto we're still following, and that's working really well. If I can't convince him to do that story, I'm probably not convinced myself we really, really, truly need it. So you better convince your product owner that tech stories are needed and that you need to do it right now. We do organize code camps where everyone comes together, and that's also the place where we spread the vision. So we don't need any architect. But who organizes those tribe meetings and the code camps? And what if there's a stalemate? If 10 people want Wildfly, 10 people want Spring Boot? And who's responsible for spreading this vision? Because we found that shared responsibility often means no responsibility at all. So we need someone. We need an architect. And this has been going on like the wave we had before. We've had an architect, no architect, we hired an architect, he left, then we appointed someone to be architect, they left, and we just hired a new architect, and it's not going that well yet, but who knows? Maybe I'm next, but yeah, that means I have to leave soon, and I don't know. So yeah, we've struggled with that, and we haven't found anything that always works, but yeah. We've got self-organizing teams, and self-organizing teams are great. So if I want something, I can make it happen. I've got complete freedom. If our team, like we did last week, if we decide we don't want to have 5 teams, but we want to go back to 4 teams, then we do that. We have that freedom. We can literally decide anything. We can't just do it, but then we can convince people that it's necessary, and for example, the product owner, and then we do it. And yeah, that freedom is very good. You want to have that freedom. But we also have a shared responsibility. But that often means we have no responsibility. Our application has a lot of big, scary things that I know of that no one feels responsible for. Because, well, it's not my problem, it's our problem. So I'm not going to say it in this meeting. They should say it. So shared responsibility isn't the silver bullet. It's good that you have the freedom, but I think it's very good to just appoint someone, you're now responsible for that. And every meeting where you're talking about that thing, he or she should stand up and say, wait, we need to fix this because... So, yeah, shared responsibility isn't really working that well for us. Microservices. Well, we had a lot of problems. We had one front end, the Swing thing, and we had one big back end, but the deployment cycle was way too long. First of all, we needed to bring down one node. First of all, we needed to build it in Jenkins, which took like 20 minutes or something. Then we needed to take down one node, deploy it, slowly migrate the users, bring that node up, and it took like a couple of hours to deploy a new version. But it was okay, because we're doing it once every 2 weeks. Yeah, but microservices, come on. The biggest problem is we're stuck with old technology. We're using Swing and a pile of EGBs. It works, but the problem is it's not sexy. And that sounds like a stupid problem to have, but for example, we needed a new developer. So I went into my own company, where we have a lot of good developers. I said, there's a position available, do you want to work at our project? Yes, we've got a very cool team, and we eat pizzas, and we do fun stuff, and you can just make anything happen. Cool, what are you doing? Yeah, we're making a Swing application with EGBs. It's like, I'll skip. And that was a big problem. We couldn't get any good developers. So it was just not sexy enough. We have to move on. We started out with a 3-tier design. Anyway, everybody knows the 3-tier design, right? You have the presentation layer, the business logic layer, and the data layer, and that's how the entire application was made. Then we started to move towards an hexagonal design or clean code design. I'll go there in depth in the next slide what it is. And now we're doing microservices. So for the people who don't know an hexagonal design, I just quickly drew this, but basically in the middle there's your shared business logic, your domain, and on the outside there are facets where you communicate with external services, like the database or REST calls or users, and you have like pizza slices of functionality. So yeah, that makes it easy because transitioning to a microservice, we could just take one functional pizza point, pull it out, make it into a microservice, and deploy it. So how do we make a smooth transition? We don't want to work for weeks or months or years to make everything into microservices and then deploy it. Everything we've done up to now, in the last 10 years, every change we made was done in a smooth manner, where we go live every 2 weeks and the users have something new. So how are we going to move from one monolith to microservices, from one Swing GUI to something else? For the front end, we decided to replace the JPanels with JX browser panels. For those of you who don't know the JX browser, I had never heard of it before I started working here. It's like a small Chromium browser in your JPanel. So we could make Angular applications and run those in a JPanel. It's not a complete solution, but it allows us to make Angular applications, which is sexy. And it allows us to have a smooth transition. But one of the big scary things I mentioned is we have no plan whatsoever to go from that Swing with dockable things to something in a browser. Like, we don't have that. We just create the same panels as we did before, but they are now Angular panels. In the backend, yeah, like I said, we could just cut it up and place pieces, and especially new parts of the application, we make microservices. The data storage, we still use the Oracle database because, well, it's there. We had no need to replace it. But for each microservice, we have a separate schema, so the data itself is really separated. It's just running in the same cluster. If we wanted a MySQL database, we could just take the data, put it in a MySQL database for that single microservice. But yeah, we've already paid the license fees for Oracle, so we'll just use Oracle. No problem. Right now we have 20, probably when I get back 30 microservices, and we have a lot of technologies. So some of the services are still Wildfly applications in a Docker. Some are Wildfly Swarm applications in a Docker, and some are Spring Boot in a Docker. Why do we have all these different technologies? Well, it's sexy. People are free to pick. If I want to do something new right now, if there's like entirely new code, I will probably take Spring Boot, because for me, it's the easiest way to get something new working. But if I have to pick something from the old EE application, migrate it to a microservice, it's all Java EE, so I'm better off using something like Wildfly Swarm, because I can literally take the same code, put it in a microservice, package it with Wildfly Swarm, and it just takes the Wildfly components I need and have like a mini application server running Java EE. Maybe microprofile will be added, because we haven't experimented with that, but that should work as well. We've got 10+ Angular projects. They're in a separate Docker, and we run it with NGINX. It says Angular 2, but we also have some Angular 1 applications. We have some Meteor applications. It's just a mix and match of different technologies. We still have the backend, because I think 60% of it is still in the monolith, and in the front end, there's even more in the front end still in the monolith. So teams are picking their own technology, and that's good because you have total freedom and creativity, and you can use state-of-the-art technology. If some magical new framework is created tomorrow, and I like it, and I think it's production ready, I can use it tomorrow. That's cool. But what I found is that microservices deteriorate much faster than our code used to. We used to have one monolith, and for every change we did, we updated the entire code base. So for example, if we went from Wildfly 9 to Wildfly 10, we would update the entire code base to Wildfly 10. If we would go from, we are also using Spring, if we would go from Spring 3 to Spring 4, we update the entire code base to Spring 4. That became hard to do, but we did maintain the entire code base. Right now, we don't do that anymore. Like I said, we've got a lot of Angular 1 projects, then Angular 2 came out, and the new projects are Angular 2. The old ones, we don't touch anymore because they're running, and yeah, we don't need to update them. They deteriorate. But yeah, you could say they are small enough. If there needs to change, if something radically needs to change, we'll just make it again in Angular 2, or Angular 5, or Angular whatever, or some other framework. But somehow it doesn't feel quite right. We've noticed more drawbacks. A lot of code is being duplicated now. In the old monolith, you don't do code duplication because, well, it's right there. You can call it and that's it. But even things like a date picker, we've got a Meteor date picker, which has a lot of common code with the Angular 1 date picker, which has a lot of code with the Angular 2 date picker. But it's duplicated 3 times. We've got messaging code for Spring Boot and for Java EE. And it does basically the same thing, but if we find a bug there, we need to fix it in all the Spring Boot applications, and we need to find a different fix in Java EE to fix all the Java EE applications. That's something we recently had. The settings are different. So it's more of a hassle. And it's much harder to manage and to monitor. Because in the old application, the monolith was there, or it wasn't. And all the code you could call. Right now, maybe the microservice isn't there. Maybe it's temporarily offline. Maybe it's for every call I make, and we make a lot of small microservices, you need to be aware of that things could be going wrong. The network could be offline. Those problems weren't there in the monolith. And this makes monitoring and managing the microservices a lot harder, because you really need to think about this and to properly decouple it. I've also noticed that the coding style is diverging. Every team is responsible for a couple of microservices, and they only work on their own microservice. When we had the monolith, all the teams were working on the same code base. But not anymore. Now everyone is on their little island doing those things in their own little microservice. If you want to break up your monolith into microservices, start easy. Just pick something that's already like completely separated, but it's in the same code base, that's easy to pull out and make into a microservice. And from there, you can pick the next thing, pick the next thing, pick the next thing, until you're left with the last microservice. There's a catch. In our case, the thing we don't want to touch, which is horrible code, is everything related to traffic, like the vessels and when it arrives, when it leaves, that kind of stuff. The core of our application. It's also the core business of the port, obviously. But that code is horrible. And so we started picking away microservices, and each microservice we pulled apart had like a very clean API, but a different API to calling the traffic stuff. So if we would continue and not think about how that traffic API should look like, we'll end up with some horrible code which has like 30 different ways of talking to the outside world. And that's something you really don't want to be left over with, because then you need to change all your microservices once you get to that final traffic thing. So it's better to create internal APIs. We've done that for traffic now. We've created an internal API. The code's still in the monolith, in the backend, but it has its own little API that all the microservices need to call, and we're already thinking about how what that microservice would look like if it was just a microservice, but it's still in the monolith. So from the beginning, try to make separate APIs already in your code. And you can do this in your monolith. It will make it much easier to separate the microservices out. Who here knows Conway's law? Ooh, not a lot of people. You're going to learn something. Conway says, organizations which design systems are constrained to produce designs which are copies of their communication structures. So, for example, what I've seen, banks are usually like large, strict organizations with a lot of rules. They usually have SOAP, because that matches the communication structure of a bank. We, on the other hand, have like a very agile team. We're very friendly, we can change anything, and everything's done on the fly. And that reflects in our application. Our application is easygoing, is flexible, and so that's a good thing. But I've noticed the inverse Conway law, or Roy's law. Organizations which radically change their system design should also expect changes in communication structure. This to me was very surprising. I did not expect this, but because we chose to do microservices, where all the teams are working on their own little microservice, the communication style changed. We don't feel responsible for the entire product anymore. We only feel responsible for our microservice. If the dangerous goods microservice fails, I don't care. It's their microservice. If production goes down, well, let's see who we can blame. We didn't have this blame culture before, but now because we moved from a monolith where everyone was responsible for all the code to the microservice, we've also changed our communication structure and our team dynamic changed and our culture is changing. This was something I really wasn't expecting, and it's not changing in a good way, if you ask me. So that's something to keep in mind. If you want to go to microservices, it will change. You get other team cultures. Who here knows cargo cult? So this is a tribe in Melanesia, and they were like a very basic tribe, picking berries and killing animals and eating them. But suddenly World War II happened, and planes started to land there, and they were introduced to luxury goods. And they loved luxury goods. We all do, but especially they wanted all the t-shirts and knives, and it's so handy. World War II ended, the planes left. So the Melanesians started to think, how can we get the planes back? You know what we should do? We should build runways and wooden planes, then the planes will come to us. Because that's how it works, right? What does this have to do with IT? Well, Spotify does X. Spotify is successful. Now, wait a minute, we don't do X. If we do X, we'll be successful. No. But it's something that happens, I see it happening in our project, but in everyone here now thinks, oh, what that Roy guy is doing, that's really good, but we need to do that. Maybe, but don't just do it, think about it. It's closely related to survivorship bias. I've got 2 kids, and when I go to my grandparents' place and I find some old toy like this bus, I can guarantee you, if you do the same thing, you go to your grandparents' place and you find a toy, they will say, oh, the toys they made 30, 50, 40 years ago were so much better. They didn't break, they still survive. Look, it's still here. But that's a myth. All the toys broke 30, 40 years ago, but you can't show them. They've long disappeared in the trash can. Currently, toys break, and you see those toys break, but I'm pretty sure my kids have toys that will last another 30, 40 years. But I just don't know which ones they are. But if you just look at the ones that survived, that's the idea you could get. Toys were better because we still have them. Another example, again in the Second World War, is a British plane. The plane got a new engine, and they could add armor to the plane. So whenever a plane landed, they would note down where all the exit holes from guns were, and they would draw a map like this, and the generals would go into a big room, and they would say, so we definitely need more armor here, and around here, and maybe also in the tail. Until one very smart general came, he said, nope, we're not going to do that. We're going to put armor right here, and right there, and there. Why is that? Because they were counting bullet holes in planes that landed. The planes get hit everywhere, but if you get hit here, you don't land. If you get hit there, you don't land. That's a typical example of survivorship bias. And that's true in IT as well. I've been to a conference and I've heard 3 talks on a successful project doing microservices. Well, that's mainly because no one talks about failed projects using microservices, but you don't want to stand here and talk about, we had such a horrible project and it failed. That's not fun, so that's not what you are hearing. And also, there are probably more successful projects not doing microservices, but it's not hot, so no one is talking about that. So keep that in mind. It's important. Back to the timeline. At present, it says sprint 168, but actually it's 169 now because the sprint ended Wednesday and it's now Thursday. So we still have challenges. We have those big, scary things that are left unfinished, which no one feels responsible for. Oh, wait, that's the next bullet. No one feels responsible for those things. For example, the big swing application, the dockable frames. Sure, we are making Angular 2 frames now, but they're still inside that little, we have no solution for this. And I'm afraid if we continue, we've got a lot of small Angular 2 panels. How do we put that into a new application? I've got no idea. There's no vision whatsoever. We've went this way and we're going this way, but nobody questions this. So probably shared responsibility, so maybe I should say something about it, but yeah, we're not. We don't have a vision about the architecture, about this swing thing, about the product. But hey, we'll be okay. We are agile. We'll evolve. We'll find a way. If you have questions, or even better, if you have answers for me, please raise your hand and ask them. Seriously. Anyone?